All right, friends. So today we're going to be talking about group designs with regard to experimental research. They come in a variety of different flavors, and what you always want to keep in mind with this is what is going to be the best technique for examining the question you have it to examine, and then also like what's going to give you the best answer. And when I say best, I mean most accurate, most representative, um, the one on which you can draw the most like well-founded conclusions on, right? Not necessarily the answer that you want, but the answer that is correct. So things we're going to talk about real quick are just going to be subject selection, assignment, group designs, and then multiple treatment designs, which we'll talk about later on. They get a little complex, but I've got some tables that I think should hopefully get you through them pretty easily. So random selection, let's go ahead and start with this. This occurs before random assignment and is to not be confused with random assignment. So random selection simply means that everyone has an equal probability of selection, usually using a lottery system or a random number generator. All right, so if I was to do one here at HBU, I might randomly generate H numbers and contact those students to be part of the study. All right, there is no bias in a random selection. And of course, because of this, it enhances the external validity as well as the generalizability, right? Especially, I would underline this, when an appropriate sample is selected. Let me get a drink of water, excuse me. Right? A representative sample. So I want to make sure that I get a good representative sample of HBU students, right? And that would include, for example, in the HBU's case, it would be predominantly Christian, right? Not entirely, of course, but predominantly. It would also be predominantly female. So a lot of times people would be like, oh, well, you want to make sure you get a good representation of both men and women. Yes, you do. But at this school, there are more women than men. So therefore, our sample should contain more women than men. All right. And of course, we always want a large generalizable sample, but that's not always possible. When it comes to college students, yes. But when it comes to nuanced situations, say female service members who are African American and have suffered from PTSD, very specific group there. And while there are people that fit that category, it's not as widely, it's not as large of a category as as undergraduate college students. What you could also do is do random sampling that is called stratified random sampling, right? So in this case, you're saying, okay, well, at HBU, I want to make sure that if I'm sampling undergraduates, I want 100 random freshmen, 100 random sophomores, 100 random juniors, and 100 random seniors for a 400-person sample. In that case, that's called stratified random sampling. It's stratified in that you're deliberately making sure that there is the diversity among like class rank, right? You want to make sure you have plenty of each, but then within those categories, you are also making sure to randomly acquire your participants. So that's going to be stratified random sampling, and it is very ideal in a lot of situations. You could do this based on race, you could do this based on age, gender, sexual identity, whatever, right? Whatever. You can do it on a variety of things, but this allows to make sure that you get good sampling across diverse subgroups. Unfortunately, a lot of psychological research does not involve this and should do. It just is sometimes more difficult to achieve than just a simple random sample or a convenient sample. So diversity, as we talked about in previous chapters, we want our sample to be diverse, but there is a limitation to this. There is such thing as excessive heterogeneity. Most research, of course, is conducted with European American males, so white males, right? Actually, this number is changing. In fact, it's most likely white females who are participating in the research. But minorities, regardless of the topic, are almost unanimously underrepresented. And when I say minorities, I'm not just referring to racial minorities. I'm referring to age minorities, SES minorities, sexual identity minorities, ability based on ability or disability, right? And what you got to think is you can only generalize to the people that were in your study. So if there are no people of color in your study, if there are no people with disabilities in your study, you cannot generalize to those groups. So just got to keep that in mind. The simple example is you should only have opinions about foods you've eaten, right? So if you're eating those fruits, right, for example, right, in that selection of fruit, there is no papaya, for example. You can't say, oh, I don't like papaya when you haven't sampled it. That's exactly the point. Do not provide conclusions, and this is not just in research, but in life, do not conclude on things that you don't have any experience with, right? Just stay in your lane. So things you want to consider as the researcher. Have you thought about the impacts of gender, ethnicity, race, SES, ability, marital status? Have you thought about how these might impact the study? And they actually might might be factors that you need to be considered of, and you might want to stratify your sample based on these factors. So give it a think. And not that they will always affect it, but there is a chance they could do, right? According to the U.S. Census Bureau, and I think this was in 2010, there was 126 different combinations of race and ethnicity in the United States, right? I only use that number to just indicate how diverse this country is. So if you offer, say, 3 options for people to pick on your study of race and ethnicity, you're leaving out 123. Now, don't get me wrong, I don't think research always needs to include 126 options. But just to give you an idea of just how diverse this country is and how this might impact your study, there's the number right there. But what I would always suggest is consider what prior research has found, and consider what demographics could have an impact, and how they might. And it's always better to consider things even if they don't. So even if you don't know if it's going to have an impact, still ask the questions so you can make sure, and rule it out as a potential confound or covariate. So sometimes, right? Sometimes you don't need a lot of diversity. Sometimes you can use a very restricted, it says restricted there, let's call it limited. A very limited sample is okay, sometimes, okay? So for example, if I was doing research on hip dysplasia in mastiffs, so mastiffs are really, really big dogs, and they can get hip dysplasia. Well, part of the reason why they get hip dysplasia is because they're so big, right? I don't need a very diverse sample in that case because not a lot of dogs commonly get hip dysplasia. So it wouldn't do me any good, for example, to sample Chihuahuas or make sure there was Pomeranians in my sample because those dogs typically don't get it because they're not very big, right? When it comes to something like Pavlov's dogs, in that study, it's a study that almost everybody is familiar with. Hopefully all of you are familiar with at this point in your psychology career. Did it matter what kind of dogs Pavlov used? Did it matter? I know it sounds like I'm waiting for an answer from you because I won't because we're talking over the internet. But no, it did not matter at all. It could have been poodles or it could have been pit bulls because fundamentally they would both do the same thing. They would both have the same response. They would both salivate or learn to salivate at the sound of a bell based on classical conditioning, right? And granted, the poodle would probably salivate less and that pit bull would salivate more, but they would still salivate as a result of the classical conditioning. So there's not really a concern in either of these studies whether or not the study is particularly diverse. Obviously, these are extreme examples, but I just want to keep it in mind. Samples of convenience. Ugh, I'm going to have to take a drink before this one. My Chick-fil-A unsweetened tea. Obviously, the name gives it away. They are convenient, and I used the metaphor in a previous lecture of 7-Eleven versus Costco. Can you get a meal at 7-Eleven? Yes. It's convenient, it's fast, it's cheap. Is it a good meal? It probably will not be. Don't want to judge, but probably not. If you go to Costco, can you get the materials for a meal? Yes, but it's going to be a lot more time consuming, more expensive, right? So samples of convenience are typically college freshmen, right? And there is a place for this. And if your study, for example, is examining college freshmen, if that's the population you want to generalize to, then go ahead. Sample them all you want, right? But otherwise, you need to make sure that your sample is representative. So if you want to know, for example, if you're doing a study on gerontology, study of it getting old, right, or aging, college freshmen are not the people you want to ask. What the heck does an 18-year-old know about getting old, right? They don't have any insight into that. Ask people who live in a nursing home, or ask people that are about to retire, or ask people that are at least in their 50s, not that 50 is old, right? But we want to make sure that we use the appropriate subjects when conducting our research. Random assignment. So in your notes, make sure we're clear. Separate from random sampling, random assignment should come after random sampling if they're both in the study, right? And let's not forget, random assignment is one of the prerequisites for a full experiment, okay? Once again, subjects have an equal probability, but this time of being allocated to a certain group, right? Once again, using a random number generator. And it's ideal to have equal group sizes, right? So let's think of it like this. If I have a penny in my hand and I flip it 100 times, it might be possible that I get 30 heads and 70 tails, right? That's not equal. Probability dictates that I should get about 50 and 50, but it doesn't always happen that way. So ideally, you want to end up close to a 50-50 split, but randomization doesn't always do that. So don't violate the randomization for the sake of equality, right? What it does is it minimizes bias, minimizes confounds, and ideally, the characteristics of the sample are spread evenly across the two groups, or more. You can actually, I'm using the example of 2 groups, but you could have 10 groups if you need to. right? Random assignment is a very useful tool, but of course not possible if you don't have more than one uh, group, or if you have groups that are predetermined. So if your study is examining the difference between men and women, random assignment is a moot point because you can't assign them to groups to which they either belong or don't belong already. You get the idea. Group equivalence. So in this kind of assignment, we want to make sure that the two groups are as close or similar as possible, right? So what we're trying to do is, if we were looking at study habits, right? We want to make sure that, okay, we have the same number of 2.0 GPA students as we have 4.0 GPA students in both groups, right? The idea is trying to make them as equivalent as possible. And as the slide indicates, this is more of a concern when the groups are small. If the groups are big, doesn't really matter. If you've got 1,000 people in one group and 1,000 people in another, you don't really have to worry about group equivalence. But if you've got 10 and 10, it is very important that you examine the equivalence issue, because it's possible that in a 10 and 10 split, you've got a certain quality or demographic that is impacting your study more than the treatment itself or more than the independent variable itself. So I keep saying keep that in mind. I don't know why I end every slide with keep that in mind. Remember it, please. Matching. Matching is a like equivalent, but to the next level, even more detailed. So basically, you're sorting the groups into equivalent matches, but you're making sure that you do it subject by subject, right? So if I'm going through and trying to distribute them to two groups, I might say, okay, well, group A, I'm going to put a white 20-year-old male in that group. So now I have to put a white 20-year-old male in the other group. This is a black 23-year-old female. She goes in group A, so I need another black 23-year-old female to go into group B. What I'm doing is deliberately pairing these subjects off, matching them across the groups. And the idea is that this once again allows me to reduce the number of confound variables, because both groups are as identical as possible among certain factors. So in that case, I can't really say, oh, well, it was because of race or ethnicity, because the groups are equal in that respect, or age group, or whatever. You get the idea. If the groups are equal in all other ways, then what is left must be what's impacting the study. Mismatching, I'm going to go ahead and say it. I don't want to like to editorialize too much in my lectures. It's stupid. It's stupid. Okay? I don't like the idea at all, because essentially it deliberately biases your study. So what you do is you try and make the groups different to see if there is if the quality in which they are different also has an impact on the study. I don't like it. I don't think you should do it. Let's pretend we didn't talk about it. All right, so some selected group designs. I'm going to lay this out. I'm going to lay this first one out briefly. I'm going to pick up the lecture in just a second with this. What I would do, if I was you, is I would draw this little table in blue in your notes and label it. I'm about to tell you what to label it, right? So there are two groups. If we look at the horizontal lines, right? So there's the top line is R01X02. That top line represents the experimental group. That line just below it, R03 space 04, that is the control group. Okay, so I would want you to label it that way. R represents random assignment. In both cases, both groups are randomly assigned. O, in any case, is an observation. Right? O1 and O3 represent the pre-test observation or measurement, however you want to describe it. Pre-treatment, pre-test, pre-manipulation, right? O1 and O3. X is the treatment or manipulation. And notice only one group is getting it. Only the top group is getting the X, the treatment or the manipulation. And then O2 and O4 are the post-test, post-treatment, post-manipulation test. That's how I'd ask you to label it, and we'll pick up the description of it in just a moment.